All right, so now we're going to generate our real consumption aggregates. First is now just to take you through the code snippet where we're going to generate these expenditure categories as well as um, uh, the per capita expenditures. So let me copy the code that we're going to go through, and then I'll take you through it one by one. Okay. So first, we're going to generate the real food expenditure values by dividing by the per share price index, which is just X over P. And then if we again describe our expenditures, we know exactly which expenditures we have, or the expenditure categories are these ones. So what we want to do is we're going to also create a var list where we have the particular expenditures that only relate to the food consumption. Recall that we can only deflate using the price, the per share price index or the other equivalent factors based on only these two, the expenditures related to food consumption. So according to our list, we have expenditure category 1.1, expenditure category 1.2, expenditure category 0.21, and expenditure category 0.22, as well as 1.1. So these are 0.1, 2.1, 2.2, and then we have 2.1. All right. Let's see properly, making sure that we're taking the right ones. Yes, there is 2.1, 2.2, and then we have 1.1. Okay, so 1.1 again is here. These are vendors, cafe, restaurants, and then the 2.1s. If we haven't missed them up there, yes. So you have 2.1, 2.2, tobacco consumption, alcohol consumption. Pretty much, this can be categorized as food expenditures. Okay, so what we're going to do is just to generate what we call a real based on food consumption aggregate, which is this bar. It will be that real. We're just dividing this each particular variable by the per share price index. Okay, so let's run that. And then again it will indicate that two missing values have been generated. Then the second one, we're going now to construct based on that function that Deaton and Zaidi had also indicated that this is how you should compute it. So recall that we just used we used the deflator. It's just the opposite of this, and then we're going to again we can describe the expenditures. Of course, here in this case we don't need, but it will be the same food expenditure categories where we're also going to generate a real expenditure. We're just calling A for added equivalence. It will be the same structure as we've done with the per share price index, and then we divide by the P, the P index, or based on the added equivalence. So that too again will generate two missing values. Then the next we're going now to generate now the real expenditure aggregates, now based on the P index for the non-food, because all these are the expenditure aggregates. So expenditure aggregates 0.3 to 3.1 to 101, and then from 112 to 124, and then 0.43 to the last one, which is 144. This will be based on the non-food price index. Okay, we run that, and then again you see there are no missing values. Then we're going to generate the real total expenditure category, which is now the first one here. We're looking at the one based on the per share price index, which will be the RF expenditures, and then plus the non-food expenditures. and then we also generate the real expenditure category, which is now based on the added equivalence as the the real added expenditure category variables, and then the sum of the non-food price, the non-food expenditures, right? So we can also run these two because we're looking at the total real food consumption aggregates. The reason why we're doing this is that even when we are computing the poverty line, it has to be different for the one that is using the per share price index, and then also the one using the the added equivalent scales, because those two are different units. Then lastly, here we're now going to generate the per capita real variables for all the consumption aggregates. Then looking at the one that we've created just now, and then the other food, as well as the added equivalence, as well as the the non-food consumption aggregates. Then we can just generate this and then just label it per capita. We're just dividing this by the household size, right? So if we run that again, we have now generated in these variables only two missing variables. Okay, so next we can also inspect our data, do some descriptive stats, just see how our data looks like. We're going to run these code snippets. So we inspect the real expenditure, the total real expenditure based on the per share price index, and then also we're going to also explore the one that is based on the one based on the added equivalent scales, and then we can describe, of course, just to see them, and then basically, as you can see, that these are the numbers that are coming up, all right? And then we can also do the same for the real consumption aggregates based on the added equivalence, and you could see how they differ with the others. So again, this is just showing the lowest and the highest. All right. Okay. You can view those. All right. Then, as usual, it's important just to view the graphs of these scales. We just copy and paste here. We're going to run similar cases. The graph, the graph ball, the box plot histogram of the food, the one based on per share price index. Let's just run that to see how it's looking like. You can see a lot of outliers in the data set, and then also the same for the per capita one. It will also showcase significant outliers as well. Okay, yep, outliers there. And then we can also do the same for the one based on the added equivalent scales. Not different at all. Significant outliers, and also really skewed to the left. And then the last one being on the per capita, also indicating pretty much the same. Next, what we're going to do is now to label our variables of interest. We start with the real expenditures that we've also constructed, and then also label the per capita values. So these are pretty much the same. This is how we label them. Then based on this, this is from 0.55, and then also from here all the way, this is how we label them. So we're going to run this as well, because these are the variables that we've generated. Okay, and then we label also the per capita variables pretty much with the same information. Okay, so per capita again will be similar, where you have just saying per capita household food, and then it also falls with the same, because here we're looking at from here to 1 to 1, and then also the last one as the value labels that we're going to the variable labels that we're going to include. So run that as well, and then that should also generate those data. We label those data. Then lastly, what we're going to do is add nodes to our data. We're going to say, okay, this is now Malawi IHS 5 consumption expenditure subcomponents that is based on coding, and then we add this as a new label, and then also we keep the variables of interest, because recall that this is just looking at real consumption aggregates, and then we're going to save our data file. Okay, so we keep the case, the weight, the household size, and then the real expenditure aggregates that we've generated, as well as we're just gonna keep the nominal expenditures at the end, which of course you may or may not, but these are just data that we can also match with the variables DTFI. Okay, then once we run this, we have kept the data. Always make sure that everything has been labeled, as is the case in this DTF file, which is great. And then once that is done, we can now save our data file as now looking at IHS 5 expenditure data file 0. Okay, so run that, and then we've saved our data file. So next we're going to generate the 14 consumption aggregates that we can also further use to also compute the and then compute the poverty line, and then come up with a poverty measure that we can also